You know that feeling when your project starts small and clean, but then it just grows into this tangled mess? Well, today we're cracking open the Software Architect's Toolbox. We're going to walk through 7 classic structural design patterns. Think of them as your secret weapon, proven blueprints for building software that's flexible, scalable, and won't collapse under its own weight. So, here's our game plan. First, we'll tackle the why. What's the big problem we're even trying to solve? Then we'll dive into the patterns themselves, grouping them by what they do best, adapting things, wrapping things, and simplifying whole systems. We'll even look at how to structure hierarchies and save a ton of memory. And don't worry, we'll wrap it all up with a handy cheat sheet.
All right, so before we start looking at the solutions, let's really get on the same page about the problem. Why do we even need these patterns in the first place?
We have all been there, right? A project kicks off, everything's great, but as you add more features, it slowly turns into this tangled web. Every piece is connected to every other piece. You change one tiny thing over here, and suddenly something completely unrelated breaks over there. That right there is the core challenge that structural patterns were born to solve.
The best way to think about these patterns is not as new code you have to write, but as tried and true recipes for putting things together. They are blueprints for how objects and classes should relate to each other. It's all about creating systems where you can swap out parts, add new things, and make changes without a massive domino effect of failures. It's about mastering those relationships.
Okay, our first set of tools is all about adding new tricks to old dogs, so to speak. These are the patterns you reach for when you need to change how an object behaves or what it looks like, all without actually touching its original source code. First up is the adapter. And man, this pattern is an absolute lifesaver. You've got 2 perfectly good pieces of code, but they just can't talk to each other. It's like they're speaking different languages. The adapter pattern acts as the universal translator between them. This analogy is just perfect. The travel adapter doesn't change your laptop's plug, and it certainly doesn't change the wall socket in Europe. It's just a simple, elegant bridge that makes 2 incompatible things work together seamlessly. That's exactly what the adapter pattern does in your code. Next up, the decorator. So what if you need to add new features to an object, but you want to do it on the fly, dynamically? Well, that's what the decorator is for. It's this incredibly flexible alternative to creating a whole mountain of subclasses for every single possible feature combination.
Let's really lean into that pizza analogy. Your plain pizza crust, that's your base object. Each topping you add, the sauce, the cheese, the pepperoni, is a decorator. You're just layering on new functionality, and you can mix and match them in any combination you want, all without ever changing that original crust.
Okay, rounding out this group, we've got the proxy. The proxy pattern is all about creating a stand-in, a placeholder object that sits in front of the real object. And this little layer of indirection, it gives you an incredible amount of power and control. That's it exactly. Your credit card is a proxy for your actual bank account. It lets you buy things without giving every cashier direct access to all your money. In code, a proxy can do things like lazy loading, so a really heavy object only gets created when you actually need it, or it can add security checks before letting a request go through to the real object. All right, let's move on. Our next pattern is a big one, and it's all about tackling overwhelming complexity. You know, when you have a system with a million moving parts, sometimes the best thing you can do is just hide it all behind one simple, clean front door. And that front door has a name. It's the facade pattern. Imagine you're working with a super complex library that has dozens of different classes you need to wire up just right. The facade gives you one simple method to call, and it handles all that complicated orchestration for you behind the scenes. When you start your car, you just push a button, right? You don't care about the spark plugs or the fuel injection system. You just want the car to start. That's the power of the facade. It gives your client code a simple start button, making everything dramatically cleaner and easier to use. Okay, now we're getting into some really powerful stuff for organizing complex structures. These next 2 tools help you build tree-like hierarchies, and, this is super important, keep different parts of your system from being too tightly welded together. The composite pattern is just brilliant, especially for anything that can be thought of as a part-whole hierarchy. The key idea here is that it lets you treat a single item, what we call a leaf, and a whole group of items, a composite, in the exact same way. A file system is the textbook example. A folder is a composite because it can contain other things. A file is a leaf. It's a single object. But here's the cool part. a folder can also contain other folders. The magic is that you can run an operation, like get size, on a single file or on an entire folder full of files and subfolders, and your code doesn't have to care about the difference. Next up, the bridge. Now this one's a bit more advanced, but it's incredibly powerful. You use it when you find yourself with two separate things that can change independently. Instead of making a new class for every possible combination, the bridge pattern splits them into two separate independent hierarchies, the abstraction and the implementation. This is a fantastic way to visualize it. You can have different kinds of switches, a basic toggle switch, a dimmer switch, those are your abstractions, and you have different kinds of bulbs, LED, fluorescent, those are your implementations. The bridge connects them, which means you can invent a new type of switch without having to rewrite any code for the bulbs, and vice versa. It prevents that huge explosion of classes. All right, our final structural pattern is a bit of a specialist. You pull the flyweight pattern out of the toolbox when you're facing a very specific problem. You need to create a massive number of similar objects, and you're worried about blowing out your computer's memory. So here's the magic trick behind the flyweight. It splits an object's data into two buckets. First, you have the intrinsic state. This is the heavy, repeatable data that's shared among many objects, like the 3D model and textures for a tree in a video game. Then you have the extrinsic state. This is the unique data, like each individual tree's X, Y, and Z position. By sharing that one heavy 3D model across thousands of trees, you can render an entire forest without running out of RAM. Woo! All right. We have just flown through all 7 structural patterns. I know that's a lot to take in, so let's pull it all together into one simple cheat sheet to help you remember which tool is for which job. This table right here, this is your key takeaway. It connects the problem you're facing directly to the pattern's name and an analogy you can actually remember. You need to make 2 things work together? Think travel adapter. You need to add features on the fly? Pizza toppings. Decorator. You need to hide a ton of complexity? That's the car start button, the facade. Feel free to pause here and really let this sink in. So at the end of the day, this isn't about just memorizing 7 names from a textbook. It's about training your brain to see the underlying problems of complexity and rigidity in your own code. These patterns give us a shared vocabulary and a set of proven, battle-tested solutions. So the real question isn't what these patterns are, but rather, when you face that next complex problem, how will you choose to structure it?